Hi, I'm Angie Jones. I'm a certified Java programmer and Java champion. I was inspired to create this course because Java's object-oriented nature makes it a perfect choice for modeling real-world systems and domains. In this course, we'll learn the basics of Java, practice both object-oriented and functional programming techniques, gain exposure to modern Java features, and exercise concepts with fun, hands-on coding challenges. I hope you enjoy the course. Our assignment was to write a program that calculates an employee's gross pay, right? So we want to, one, get some input from whoever is going to use this program, asking them about their number of hours worked as well as their pay rate. So within the class, you need methods, and then you can write code within the methods. And we'll have a whole section on methods, but for now, trust me, we're gonna write a main method, and the main method is where all Java applications start from. So it's gonna look for a main method when the program runs, and it's going to start executing that. So to write the main method, it has to be exactly like this: public, static, void, main. And inside of parentheses, you're going to write string, a set of square brackets, and then args. And then within the main method, we can write our code. So again, we're going to do output. We're going to say system.out.println. And then we're going to print a string text. This is within quotation marks, okay? So we can ask them, how many hours did you work? And then we're going to want to read this back in. So we can use what's called a scanner. So it's a class in Java. Java provides it automatically. So when we write scanner, notice there's an error right here, and there's also a suggestion. So I can click on this, and I basically did the shortcut that IntelliJ told me, which was option and return, and it imported this scanner for me. So if you want to use a class that it's outside of this one, you want to use any of its methods or anything like that, you need to import that in. So we'll say scanner, we'll call it scanner equals new scanner. And we want to read from the input, the console, so we'll say system.in. All right? Now with this scanner object, we can now use the dot operator. It'll show us a bunch of methods that are available from this class. So what we want is to read from the input, and so we can do what's called next. And next will read whatever was the last thing that was on the console, okay? So this will read this in. Now, notice here, we're asking for hours. So this might be a whole number, an integer. So we want to read specifically, there's a bunch of methods here. Next is going to read a string, and we can read next int to say, I'm expecting an integer to come back here. Java is a statically typed language, different than JavaScript, meaning that the compiler needs to know what the data type is before you can execute the program, okay? So when we declare our variables, we have to preface it with the data type. So we want to say int, which is the data type for an integer. We're going to give the variable a name. We'll call it hours, and then we'll put an equal sign, okay? So on the left side of this equal sign is the declaration of the variable. On the right is the value that will be stored in that variable. Good? All right. So we have how many hours they work. We also need their pay rate. So let's ask them another question. To do so, we're going to do another system.out.println. So how many hours did you work? And now we need to know, what is your hourly pay rate? Okay, we want to read this in again, right? So we've already declared scanner on line 10. We don't have to do that again. We can just use it again. And this time we're asking for a pay rate. Could be a decimal number. So instead of int, we're going to use double as the type. And then we want to name this variable. We'll name it rate. Variables, convention, start with a lowercase letter. And then we'll say scanner dot next double, right? We're reading a double. Now that we're done with the input, we can go ahead and close that scanner. So we'll just say scanner dot close. Notice every statement in Java ends with a semicolon. This is not optional. It must end with a semicolon. So now that we have our input, we can do a calculation. So in order to determine their gross pay, we can say hours times rate. What would be the data type for that? You're multiplying an integer times a double.
Double.
Double. Good. So we're going to say double. Let's call this pay rate. Notice 2 words. Again, variables cannot have spaces either. If you're doing a multi-word, you use the camel case, started with a lowercase. Double pay rate equals hours times rate. Great. And now we can print this out to the user. So we'll say gross pay. I'm going to put a little space there. Now I want to append the value from the variable to this string. I can do that with a plus sign, okay? I just write the pay rate right here, okay? Good to go. Should we run it? All right, let's go ahead and run this. Lovely. So we see on the console it's asking how many hours did you work. I'm going to say 40 hours. And pay rate, let's say maybe $15.50. Okay, so the gross pay would then be $6.20. So there are 4 main principles to object-oriented programming. We talked about encapsulation already, and now we're going to talk about inheritance. So inheritance is where one class inherits the members of another class. So there are 2 parties that are involved in an inheritance relationship, a parent and a child. So the parent is known as the superclass. Sometimes it's also referred to as a parent class or a base class. In this example, person is our superclass. And then the child is known as the subclass. This is sometimes referred to as a subclass or a derived class, or a child class, sorry. Child class or derived class. And in this example, the employee is the subclass, all right? So an inheritance relationship is known as an is-a relationship. An employee is a person, right? And being a subclass is a specialized type of person. A POJO for a person. Now let's create another class. Make sure you all have this one. You got it? All right. So let's create another class also under inheritance. This one we'll call employee. And we want the employee class to inherit from the person class. To inherit from another class, within the class's header, you would specify that this class extends. Extends is the key word that forms an inheritance relationship. And then you would specify what class this inherits from, so we can write person. And that's it. That's all you need to create this inheritance relationship between these 2 classes. Now, everything that is not private within the person class now also belongs to the employee class. It has inherited these things from it. So you can inherit from a superclass, but then remember the subclass is some specialized version of that class. So you might have things that are specific just to an employee. So we can add anything we want to this. So we get whatever that we inherited from our superclass and then whatever we define for ourselves. So some attributes for an employee might be an employee ID and maybe a title. We could go ahead and create the getters and setters, so we'll generate those. And great. Now we have employee inherited from person, and then also a couple of attributes and methods for itself. Now I want us to test this out. So we'll create one more class, and we'll call this one Inheritance Tester. In Inheritance Tester, let's create a main method. And we'll go ahead and instantiate the person class. So we'll say person equals new person. I have not created any constructors, but notice I'm able to call to this default constructor. Why?
Ghost constructor.
Yeah, I think I made that term up about ghost constructor. But yes, because Java has implicit default constructor if you have not defined any constructors. Okay, so we have the person, right? And then let's go ahead and make an employee object. We'll call him employee equals new employee. Okay. Now notice if I say employee, well, let me show you this. If I say person dot, the methods that are available to this person are get age, get gender, get name, set age, gender, and name. All right. So if we look in person, I think I can split this. Okay, nice. Okay, so in the person, this is the person class on the right. We have the name, the age, the gender. And in our inheritance tester, of course, we can get those things with person. But if we look at the employee object and say dot, we have get and set the employee ID, get and set the title, which are the things that were specific to employee class, but we also have the get age, the gender, and the name, which are the methods that were inherited from the person class. So let's do one more big one. As you can see, like the Stream API is really convenient. It provides a number of these operations. We've only touched on, a few of them. There's so many more that we could touch on. But what's really powerful about the Stream API is being able to join like a lot of these intermediate operations together. So let's make one more method that'll like kind of combine a couple of them so we can see it, like the power of it all. So we'll say public static void, and we'll call this like multi-operation demo. All right. So I want to say veggies dot stream. All right. That's the first thing. Gives us the stream. And then I want to sort that stream out. All right. That'll give us an intermediate. That's an intermediate operation. So that'll give us that resulting stream. Now I want to say, all right, sort it. And then I want you to filter. I give it some predicate. Maybe I want to get all of the ones that start with the C. So I can say B dot starts with C. This will also intermediate, so it'll also return a resulting string back to me. From that, let's say I want to use map, and I want to say go ahead and like turn all of these things to uppercase. So we'll say string uppercase to uppercase. Okay, map is also intermediate, so I get another resulting string back. I can say, you know what, map it again. So I can use these like multiple times with different things. So I can do something like I want to add a word in front of each one. Okay, so this one will get a little fun. We could say, all right, take the V. And what I want you to do is say v.transform. Oh, I know, right? And then in transform, this takes another functional interface. So now I'm doing like a lambda inside of a lambda. Gasp, all right? So now I can say, all right, I called it V. Let me just say W, right? W arrow. And then I want to say, put yummy in front. Yummy, yeah, with a space. And then add the W back. Ooh, all right. Now I have still, that was intermediate as well, right? Now I'm gonna go ahead and print it. I'm getting a little silly now, so. All right, so we'll say system.out, println. All right, so now you can see how you could like chain these together to do a bunch of different processing on an individual collection. So notice the output here is yummy cabbage in caps and then yummy carrots in caps.